involve any calculus at all. Words, words, words. We're reading through it, and we are told that there is a relationship between P and R, such that P over P naught is equal to R naught over R to the fourth. And the thing that the actual words that are instructions to do something start with deduce, that if the radius is reduced to 3/4 of its former value. So in this equation, here's my radius. And given that R naught is sort of what we have as the normal values for the radius and the pressure if it's not constricted, that means that what we're being asked to do is to change R to be 3/4 of the former value, and that former value is the R naught. And then it basically says what happens. So if I replace this R with 3/4 of R naught, then I'm going to end up with P over P naught is equal to R naught divided by 3/4 of R naught, all raised to the fourth power. Those R naughts are going away, and dividing by 3/4 is the same as calling that a 4/3 to the fourth power. 4 to the fourth. So I'm going to do an intermediate step. 4 to the fourth is the same as 4 squared squared. So I'd have 16 times 16. And in the denominator, I'd have 3 squared times 3 squared, or 9 times 9. And I'm going to get 256 over 81. The other thing that Dedell said this morning is that in this section, in 6.3, he is expecting you to use a calculator. So if this were an exam problem, I'd quit here. But because he is expecting us to use a calculator to finish up in section 6.3, I'm going to reach for my calculator, and I get that this is about 3.16. Returning to the statement of the problem, we were asked to deduce that if the radius for the artery is reduced to 3/4 of its former value, then the pressure is more than tripled. So this tells me, if I were to multiply that P naught over, that the current pressure is about 3.16 times the pressure with no restriction. So we have proved that it is more than tripled. I don't know if that was very satisfying, but there's actually no calculus